Hello everyone and welcome to today's class. I am Samuel. Today we're talking about units and measurements. Now, units and measurements forms the basics or foundation of physics. Why? It enables us to quantify physical quantities. Now, when I talk about physical quantities, what do I mean? Physical quantities are the properties of objects that can be quantified or can be measured. What do I mean? The area of your land is a physical quantity. Your blood pressure is a physical quantity. Your weight, your body weight is a physical quantity. The temperature, your body temperature is a physical quantity. All these are physical quantities, and units and measurements help us to quantify them. Now, physical quantities are divided or classified into two. We have the fundamental quantities and the derived quantities. Fundamental quantities. Now, what are fundamental quantities? Fundamental quantities are the basic quantities upon which other quantities depend. Now, for every physical quantity, they have numerical value and unit. Now, for example, talk about your weight or the weight of your cylinder or weight of the gas of fuel in your cylinder. If you take it after filling the gas, they'll tell you how many kg. That kg is what? The unit. Now, let me say you fill the gas to be 10 kg. The 10 is the numerical value and the kg is what? Unit. So every physical quantity has both numerical value and unit. And the fundamental quantities also have the fundamental units. And what are the fundamental units? The fundamental units are the units of the fundamental quantities upon which other units depend. Like I said before, the physical quantities are classified into two, the fundamental quantities and the derived quantities. Now, we have discussed about the fundamental quantities and their units. Let's talk about the derived quantities. Now, the derived quantities are the quantities that depend on the fundamental quantity. They are quantities that are obtained by some simple combination of the fundamental quantities. Now, the fundamental quantities they are obtained by some simple combination of the derived quantities are obtained by some simple combination of the fundamental quantities. The derived quantities also have units as the units of the derived quantities, which are obtained or which depends on the fundamental quantities. Derived quantities also have their units. Now, what are derived units? Derived units are the units of the derived quantities, which depends on the fundamental units. The derived units and the derived quantities, all of them depend on the fundamental quantities and the fundamental units. Now, I'm going to give you examples of the fundamental quantities and the derived quantities with their units and derivation. Now, examples of the fundamental quantities and their units. We have number one, length. And the unit of length is meter. Another is mass. And the unit of mass is kilogram. Another unit is temperature. Another unit is time, and the unit of time is seconds. One unit is thermal temperature, and the unit of temperature is Kelvin. Another unit is electric current, and the unit of electric current is ampere. Another unit is amount of substance, and the unit of amount of substance is mole. These are examples of the fundamental quantities and their units. Let's talk about the examples of the derived quantities and their units. Derived quantities and their units. Number one example is area. Now, if you talk about derivation is a formula. If you come to your maths, they will ask you what is the area of a circle? What is the area of a rectangle? Now, the derivation is the area, is the formula which you use to get the numerical value of that quantity. And the quantity is area. And the formula is length times breadth. And the unit of area is meter squared. Why is it meter squared? Length is distance, breadth is distance. Distance and distance give what? Distance squared. Like come in your maths algebra, x times x is what? X squared. So these are what? Distances. Derived quantity is volume. And the formula of volume is area times height. So the formula for volume is area times height. Now when we talk about area, area is already length times breadth, and volume is what? Length times breadth times height. Whereby length and breadth is already the area, so volume is area times height. And the unit of volume is meter cube. Height is also a distance. Another example is speed. And the formula of speed is distance over time. The unit of speed is meter per second. Another unit is velocity. Velocity is displacement over time. And the unit of velocity is meter per second. Now, if you look at velocity and speed, they are almost the same. They have the same unit and almost the same formula. But the difference between them is that velocity is a vector quantity. Why? It has a direction. Speed does not have direction. Speed is just distance moved with time. But velocity is the distance covered in a specified direction with time. That's why it's called displacement. Displacement is a distance moved or covered in a specified direction. Another derived quantity is acceleration. And the formula of acceleration is velocity over time. Now, the unit of acceleration is meter per second squared. Another derived quantity is energy. And the formula of work or energy is force times distance. And what is the unit of work or energy? Joule. And the formula of force is mass times acceleration. And the unit of force is Newton. Now, There are so many examples of the derived quantities. If you go to your textbook, you will see other examples like the pressure, you see other examples like the momentum, you see other examples like power. All these are examples of derived quantities. Now we have talked about the units and the physical quantities, which are the fundamental and the derived quantities, fundamental quantities and derived quantities. Now let's talk about measurement. I told you earlier that measurement help us to quantify the physical quantities. Now in physics, there are three basic quantities that we normally use, which are the length, mass, and time. These length, mass, and time are the three basic physical quantities or three basic quantities used in physics. In that case, I want us to discuss length, mass, and time and how they are being measured. Let's talk about length. Now, there are so many ways you can measure length. You can use pulsometer in engineering. They use pulsometer. They use tape to measure long distances. Now, in the lab, what do you use to measure length? We use the meter rule. The meter rule now is 100 centimeter, which makes it 1 meter. If you go to your lab, you see the meter rule that is calculated in millimeter and centimeter. The lowest amount which this meter rule can measure is 1 millimeter. Therefore, the reading accuracy of meter rule is 1 millimeter or 0.1 centimeter. Reading accuracy. What are the things you can use meter rule to measure? You can use it to measure the length of your locker or the length of your table. You can use the meter rule to measure the length of your exercise book or the width of your exercise book. You can also use it to measure the length, width, height of your class. These are the uses of meter rule. Let's talk about the next thing you can use to measure length. You can use micrometers. You can use vernier caliper. First, let's talk about vernier caliper. Now, the vernier caliper has, if you look at the vernier caliper, it has external jaw and internal jaw. It is being used to measure both cylindrical objects and some other lengths or measure distances. It has both internal and external jaws, which is used to measure things that are cylindrical that have opening inside of it. And it can be used to measure very little fractions. In other words, the reading accuracy of the vernier caliper is 0.1 millimeter or 0.01 centimeter. 0.1 millimeter is a very little fraction. It can be used to measure small or tiny distances. And then you add the vernier scale and the main scale. In my subsequent class, when I'm talking about numerical problem or units and measurement, I'm going to show you how you take reading with the vernier caliper. Now, what are the things you can use the vernier caliper to measure? Number one, you can use the vernier caliper to measure the thickness of a paper. It can be used to measure the thickness of an exercise book. It can also be used to measure the internal and external diameters of pipe. Another thing you can use the vernier caliper to measure is the diameter of a rod. Then let's talk about the next thing which you can use to measure length. You use the micrometer screw gauge to measure length. The micrometer screw gauge can be used to measure smaller or tinier fractions, very tiny fractions, unlike the vernier caliper that measures small fractions. But the vernier caliper is used to measure more smaller fractions, which is very, very tiny. Now, the reading accuracy of micrometer screw gauge is The reading of the reading accuracy of micrometer screw gauge is 0.01 millimeter or 0.001 centimeter. That is the smallest fraction which it can measure. Like the vernier caliper, it has both the main scale and the vernier scale. Both of them have been added up to get the main reading of a measurement. Then let's talk about the mass. How do you measure mass? Mass is the amount of substance or the amount of matter in an object. Now, every matter has mass, and every mass has weight. Why? Because of gravitational force acting on mass of a body. Every body with mass, every matter has weight. Now, what is weight? Weight is the force or pull with which the earth attracts every object to its center. What do I mean by that? Why is it that if you throw something up, it comes back, or you shoot a gun, it moves the parabolic path, come back to the ground? Because of what? There's a gravitational force acting on that object, which draws it what? Downward. Now that is what? Weight. The weight is with which the earth attracts every object to its center. Object of mass. Are the instruments that are being used to measure the mass. There are various instruments which are used to measure mass, and they are: number one, we use the beam balance and some other examples. Now, weight, for you to measure weight, what are the instruments used to measure weight? Use the spring balance and also use the lever balance to measure weight. Now, there are some different mass and weight are similar, but there are differences between them. Let's differentiate between mass and weight. One difference between mass and weight is that mass is constant all over the earth, but weight differs. I will explain reason. Mass and weight. Why is mass constant? Why weight? Why does it vary? This is because there is a gravitational force acting on a mass of object. That's why it's constant. For any object to have weight, it must have mass. Now, the reason why it is different is because of, if you talk about the law of universal gravitation, that is Newton's law of universal gravitation, it states that F is equal to G is proportional to M of Earth and mass of object over R squared. This is Newton's law of universal gravitation. The force of a gravitational force acting on mass between the mass of the Earth and mass of object is inversely proportional to the square of the distance between them. Now, if you talk about the Earth is not that spherical. Now, at the equator, the equator is close to the core of the Earth. Therefore, it has its own the amount of force or acceleration acting on it. But at the top, at the pole of the Earth, the distance between the pole and the core of the Earth is what? Is large. That's why as the radius or as the distance between the Earth and its center increases, the force decreases. That's why the weight always differs. That is all. Another difference is that mass is a scalar quantity, while weight is a vector quantity. What about scalar and vector? What does it mean? Scalar quantities are going to have only magnitude without direction, while vector quantities are going to have both magnitude and direction. In my subsequent class, I'm going to talk about scalar and vector and how they are being added. Now, mass has only numerical value. For example, the mass of your gas 10 kg. It has only numerical value, but it doesn't have direction. Where the but weight has direction. How? Weight acts downwards. That's why anytime you throw something upward, it comes down. It has direction. Where it's what? Acting. Now another difference is that weight, mass is the unit of mass is kilogram and the unit of weight is Newton. Weight is a force. Another difference is that mass is being measured with chemical balance and beam balance, while weight is being measured with spring balance and lever balance. The differences between mass and weight. Now, another physical quantity I want to talk about is time. Time is used to measure is a physical quantity that is used to measure events. Now, what are the things which you can use to measure time? You can use your stopwatch. You can use your can be used to measure time. Now, let's talk about dimensions. Talking about the dimensions of physical quantities. Like I said that the basic quantities that are used mostly used in physics are the length, mass, and time. Dimensioning is a way of representing physical quantities in the fundamental quantity. Representing physical quantities, especially derived quantities in the fundamental. And the fundamental quantities we're talking about are the basic quantities, which are the length, mass, and time. It's a way of representing physical quantity in length, mass, and time. In my subsequent class, in numerical problem on unit and measurement, I'm going to show you how you can relate or relate physical quantities to their length, mass, and time. Now, what are the uses of dimension analysis or dimensions of physical? You use them to check the validity or correctness of equations. In physics, they say that V is equal to U plus AT. That is an equation of motion. I'm going to show you how the equations are being, whether it's correct or what, whether it's valid, using dimensional analysis. Another use of dimensional analysis is that you can use it to derive equations. You can use it to derive equations, and I'm going to show you in my subsequent class. You can also use it to derive the units. Like I said before, that derived units, they what depend on the fundamental units. So I'm going to show you how the fundamental derived units depend, or how can they can be derived. I'm going to use dimensional analysis. Now, what are the applications of units and measurements? We are talking about units and measurements. What are the applications? Now, number one application is engineering and technology. In engineering industry, in terms of engineering and technology, for them to make a particular design, they make use of measurements to give them their particular or specific design to make their produce. And also, that's the field of engineering. If you talk about the construction industry, they make measurements and make sure to get the structural strength of building. They make measurements of the aggregates, that is the coarse aggregate and the fine aggregate, with water and some admixtures to get a particular design of what? Concrete. If the measurement is too much, it may not meet their what? Design. They take measurements to help them to get a very good strength of the building, that is structural strength of the building. Now also in the manufacturing industry, let's say in the manufacture of cement, whereby calcium carbonate is being heated with clay and some other compounds like the tricalcium silicate, dicalcium silicate, and the tricalcium aluminate. All these components, all these compounds have a particular property which is being added to cement to increase what? Its strength. If any of these compounds are in excess or in much, it will no longer give cement its unique property. So units and measurements are being used also in the manufacturing industry. Also, let's talk about in everyday life. How do you make use of units and measurements? In your cooking, sugar in your, so if you want to put cubes of sugar in your food, you cannot put five sugars in 2 cups of rice. No, you make your what? Proper measurement. Also, in your health, why do you take our blood pressure? Why do you take our body temperature? We use it to check our health condition in order to help us live longer. With this, I think we are good for today on unit and measurement. I want you to like and subscribe to get subsequent videos on other topics in physics. Thank you and God bless you.